Example 11, find the missing sides. This is a 90-degree angle, right triangle. It's got a 60-degree angle in it. So the other side, the other angle missing is a 30-degree angle. I'll just make this bigger so I can write it better. So this is a 30-degree angle in here. This is another special type of right triangle. This doesn't have that extra added feature where we can do the Pythagorean theorem from from first step. C is going to be different than D is going to be different than 7. There's no common pieces to this one. So this proportional technique for this one has to be done for this. And the one that it's going to be similar to, and when I draw my similar triangle, I simply draw it the exact same way. So right angle in this corner, put the 60-degree angle down in this corner, and the 30-degree angle up in this corner. I make them exactly the same orientation. And the side opposite 30 is 1. The hypotenuse is 2, and the side opposite 60 is the square root of 3. And every 30, 60, 90 right triangle is similar to that one. And as far as memorizing these, which you should be able to do, I'm expecting you to memorize these numbers. You guys can memorize this based on like kindergarten. Kindergarten, you say count to 3, you did 1, 2, 3, right? That's all that's happening here. 1, 2, 3, put a square root on the 3. Square root of 3 is 1.7. Smallest angle, smallest number. Middle angle, middle number. Biggest angle, biggest number. So you go, the numbers you get, 1, 2, square root of 3, go opposite the angles in order. The other one, just going back to this page real quick, the 1, 1, square root of 2. Square root of 2 is 1.4. 1, 1, smaller numbers, opposite smaller angles. Square root of 2, bigger number, opposite bigger angle. 1, 1, square root of 2 are those numbers. So again, as far as positioning things where they belong, it's not that hard to memorize this. So apply this technique each time. You should get those numbers memorized easily. So this triangle is similar to that triangle. And again, I'm going to create a triple proportion. So I'm going to put fraction bar 1 equals fraction bar 2 equals fraction bar 3. I want the objects from the first one I'm trying to solve on top, and I want to put what I know in the middle. So I don't know C, I don't know D, I do know 7, so I'm going to go C, 7, D. And then the second triangle, this one, again, the corresponding pieces, and they're just in the same places. C and 1 are both on the bottom, D and 2 are both the slanted side, square root of 3 and 7 are both on the left, right? So if you just put the pieces where they belong, so C from this matches 1 from that. 7 from this matches the square root of 3 from that. And D from this matches 2 from that. And just like that, we got our proportion built. And just to highlight what I'm talking about here about making these this way, this proportion here contains the letter C and only C, everything else is a number. So at this point I can cross multiply and get the square root of 3 times C equals 7 times 1. Divide both sides by the square root of 3, and the calculator can evaluate that. So 7 divided by the square root of 3 is approximately 4.04. And then if I take this proportion here, that only contains D. So I'm going to cross multiply, get the square root of 3 times D equals 7 times 2. Divide both sides by the square root of 3. D ends up equaling whatever that is. 14 divided by the square root of 3 is approximately 8.08. And typically this book asks for decimal approximations. There are exact answers that have square roots of 3 and square roots of 2 and stuff like that built onto them. But again, for the sake of this book, typically round to the nearest hundredth, round to 2 significant digits, those types of things happening. So I would expect you to be rounding these, so getting approximations is perfectly fine. But again, that's the technique for both of these types of problems. That's what I would use. All right.